All right, today we're jumping into object-oriented programming. And I know, it sounds super technical, right? But I promise you, it's actually built on a really simple idea that you already get. So, what is it? Let's break it down.
Okay, so to get started, let me ask you a question. What on earth does a car blueprint, with all its crazy detail, have in common with a simple, everyday cookie cutter? I mean, one makes a complex machine, the other makes a snack. What's the link?
Well, the answer is they're both blueprints. They aren't the thing itself, they're the instructions for making the thing. And that one idea, that difference between the plan and the actual product, that's the absolute key to understanding object-oriented programming, or OOP for short. So let's really dig into this idea, the blueprint versus the actual building. This is where we meet the two most important words in the entire world of OOP.
You see, in programming, we call that blueprint a class. The class is the definition, it's the recipe, it's the mold. And the thing you actually make from that blueprint, that's called an object. The object is the real thing, the car you can actually drive, the cookie you can eat. Let's look a little closer at the class. Just think of it as the master template. It doesn't describe one specific car, it defines the essential stuff that every single car we make from it is going to have. It's the general idea. An object, then, is what you get from that class. It's one single, specific house, one cookie. In the world of code, we call it a unique instance. You could use one class to create thousands of objects, but every single one of them is its own separate, distinct thing. And right here, this is where it all clicks into place. You have one passenger car class, right? From that one blueprint, you can create a very specific object, a wine-colored Astra with its own license plate. You've got one employee blueprint, and from it, you get two individual employees, Potoko and Jose. Same with the samurai class. One blueprint gives you three different colored objects. See the pattern? One plan, many unique things. Okay, so what exactly do we put inside one of these class blueprints? Well, it really boils down to two simple things: what an object is and what an object does. Let's take a person class as an example. The blueprint would need to define its properties, things like name, profession, height, weight. In code, we call these attributes. And then it would also define its behavior, the actions it can take, like walking, running, or working. We call those methods.
So attributes, that's the data. They define the current state of an object. For any specific car object we build, its attributes hold its unique details. Its color is blue, its brand is Ford, its current speed is 60. These are the little variables that make each object different from the next.
And methods, well, those are the actions. They define the object's behavior. What can this thing do? A car object can start engine, it can accelerate, it can turn on lights. And here's the cool part. When you use a method, it often changes the object's attributes. You hit the accelerate method, and what happens? The current speed attribute goes up. They work together.
Now, here is a really, really important idea in OOP. Objects don't just have data and actions, they bundle them together into one neat, self-contained package. And they're pretty protective of their data. They don't just let any other part of the program come in and mess with it directly. This idea is called encapsulation. It's like building a little protective bubble around the object's core information. So that brings up a pretty obvious question, right? If an object's data is all private and locked away, how are we supposed to interact with it? How do we find out its color or tell it to go faster if we can't touch its attributes directly? The answer is you have to go through the proper channels. Instead of just barging in and changing the data yourself, you politely ask the object to do it for you. If you want to change a property, you use a special setter method. You say, "Hey car object, please set color to blue." And to read data, you use a getter method, like asking it, "What is your color?" It's like using a guarded front gate instead of just trying to climb the wall. It's safer and more organized.
So at this point, you're probably thinking, okay, I get it. Blueprints are classes, buildings are objects. They have attributes and methods. But why? Why go to all this trouble to organize code this way? What's the actual benefit? Well, to really get the why, it helps to know what came before. In the old way of doing things, called structure programming, your data was over here, and all the functions that worked on that data were over there. They were totally separate. The huge, game-changing shift with OOP was to bundle the data and the functions that use it together into one clean, self-contained thing, the object. And that simple act of bundling things together has a massive payoff. First, because objects model real-world things, the code just makes more sense. It's more intuitive. It lets you tackle huge, complex problems by breaking them down into small, manageable pieces. And it makes your code incredibly reusable. You write one car blueprint, you can use it 1,000 times. All of this ultimately means you can build things faster, cheaper, and create software that's way easier to update and adapt down the road. So, we've nailed down the absolute core of OOP, classes and objects. But this way of thinking, it opens the door to even more powerful concepts. To finish up, let's just peek at where this logic naturally takes us next. So think about it. If a car gets its own class, its own blueprint, then it just makes sense that a truck and a motorcycle could be their own classes too, right? Of course they could. But hold on. A car, a truck, a motorcycle, they all have things in common, don't they? They all have an engine, they all have wheels. It would be a total waste of time to redefine those basic parts in every single blueprint. And that leads to this final, really powerful question. What if one blueprint could just be an extension of another one? What if you could create a general vehicle blueprint and then let the car, truck, and motorcycle classes just inherit all those common parts automatically? Well, you can. That amazing concept is called inheritance, and it's one of the most powerful features of OOP. But that is a story for another time. Thanks for joining this explainer.